Hello, 7th graders. Today we're going to look at more practice with divisibility rules. And so we're going to use the divisibility rules to try to figure out if a number is prime. So we can use what we know about divisibility rules to help us to find prime numbers in the table. This table is listed from 1 to 50. And you can find the prime numbers by eliminating composite numbers. So first, we want to find all of the even numbers. Okay, so if I go through and I start with even numbers, I'm going to stop here because I want to remind you that 2 is indeed an even number. But 2, where's my highlighter? 2 is the only even prime number. So we're going to kind of leave that one alone, okay? So we're going to start with 4. So if I count 4, 6, 8, 10, 12, 14, you're going to go through and eliminate all of those, okay? All even numbers are not prime. They are composite with the exception of 2 because you can divide them all by 2, okay? So next, you're going to find the numbers that are divisible by 3. And we know 3 is prime. So I'm going to, again, we're going to leave 2 alone and we're going to leave 3 alone because 3 is also prime. So we're not going to mark that one, okay? So another thing is the number 6 is also divisible by 2, so we won't mark that one again. So you're going to start with the number 9, okay? Oops. So it's finding numbers divisible by 3, starting with 9, and really you could take and count every 3. If it's not crossed off or if it's not even, then you would leave it. So 9, 15, moving forward, 21, any of the other ones. And you can see this nice little pattern that they had going here for, it's kind of a diagonal that they had going for 3s. So the next thing you're going to do is find what numbers are divisible by 5, okay? Well, I know if something's divisible by 5, it ends in either a 5 or a 0. So you are going to then leave 5 is prime. We know that. So we're going to leave 5 alone. Okay, and then we're going to, just go ahead and count all the other ones. So if I look at the 5, the column here with the 5s, this whole column here, 5 we're leaving, but 10, 15, 20, 25, 30, 35, 40, 45, 50, this whole column is divisible by 5 with the exception of 5. So we can go ahead and cross all those out. Those are all divisible by 5. Okay, so now look at the numbers that have not been highlighted. They're all prime except for the numbers 1 and 49. Oops. So 1 and 49 are crossed off. So I'm going to take and go ahead and cross off that one and 49. 49, I know 7 times 7 is 49, so I know that one's not prime. But I know 2, 3, 5, 7, 11, 13, 17, 19, and so forth. Those are all prime numbers. Oops. Okay, so cross those guys off. Now, we're left with all the prime numbers. If we look at this chart here, we're going to use the divisibility rules to determine if 25 is prime or composite. So what do you know about 25? Is 25 divisible by 2? Let's start with 2. Well, is 25 even or odd? I know that 25 is odd, so it cannot be divisible by 2 because it ends in a 5. So we can rule that out. The number 25 is not divisible by 2. Is it divisible by 3? Well, my rule for 3s is if I add up those digits, if I take 25, so this would be like saying 2 plus 5. 2 plus 5 is 7. Is 7 divisible by 3? And it is not, because I know that 3 will go into 6, but not 7. So therefore, it is not divisible by 3. Is it divisible by 5? Well, 25 ends in a 5, right? So if it ends in a 5, I know that it is divisible by 5. And 25 divided by 5, if I count by 5s, 5, 10, 15, 20, 25, I get 5. So therefore that tells me it is not prime, it is a composite number. Composite number, because it now has the factors of 1, 5, and 25. If it has more than 2 factors, it is composite. So that's what that tells me. Okay, so now 53, is 53 prime or composite? So we're going to start this whole process over with 53. So again, we're going to start with, is it divisible by 2? Well, 53, is it even or odd? And again, we look at that last digit right here. We're going to say, is it even or odd? Well, I know 53 is not even, it is odd, so it is not divisible by 2. Then again, by 3. Remember the 3's rule is to add up the digits. So here we're going to take and add 5 plus 3, which gives me 8. Is 8 divisible by 3? It's not, so it is not divisible by 3. How about by 5? Well, 53 doesn't end in a 5 or a 0, right? So then that tells me that 53 is not divisible by 5, okay? So 53 is a prime number. Ooh, it's prime. Okay. So walking through those. So any number that is divisible by another number is not a prime number. That's the big concept we're working on, okay? So now I'm going to have you stop this video, and you are going to go ahead and hop into the workbook, page 236, and complete that activity.